In the 1770s, the King of Great Britain visited a factory. He asked its director what he was working on recently. The director told him that he was busy creating power. This factory director was called Matthew Boulton, and the power he spoke of was a steam engine, which he improved upon with James Watt. The invention of the steam engine reduced the need for manual operations, and machines increased productivity greatly, enabling humans to change the laws of nature for the first time. But who would have guessed at the time that the Industrial Revolution would plant the seeds of change that would eventually affect the global climate? The Industrial Revolution gave us unprecedented material comforts and made life convenient. However, the environment was being destroyed at the same time. One of the most pressing environmental crises of today is global warming. Since the Industrial Revolution, the average global surface temperature has already increased by 0.85 degrees Celsius. If temperatures continue to rise, it will bring disaster to mankind. Before looking into this problem further, we should first understand the concept of energy balance. The Earth we live in is surrounded by a thin layer of air called the atmosphere. The atmosphere extends hundreds of kilometers from the ground without a clear boundary and helps to maintain life on Earth. We all know that the energy received by the Earth is from solar radiation. Assuming that 100 units of energy reach the Earth in the form of solar radiation, about 30 units will be reflected back into space by clouds and the ground. We will be left with 70 units of energy after we subtract 30 from 100. About 20 units of these 70 units will be absorbed by the air, and this absorbed energy heats the air. 70 minus 20 equals 50. The remaining 50 units of energy will reach the ground and heat it up. Once the ground, water bodies, and the atmosphere are heated, energy will be emitted into space in the form of infrared radiation, cooling down the Earth. If the Earth is heated up and cooled down by about the same extent, energy balance would be achieved, and Earth's long-term average temperature will remain substantially unchanged. In a nutshell, global energy balance depends on three factors. 1. Solar radiation that reaches the Earth. 2. The reflectivity of the Earth. And 3. The concentration of greenhouse gases in the atmosphere. Greenhouse gases include carbon dioxide, methane, nitrous oxide, commonly known as laughing gas, ozone, water vapor, and so on. These gases can absorb some of the infrared radiation reflected from the Earth's surface and will emit them in all directions. Some infrared radiation will be emitted into space, while some will be emitted back to the ground to further heat the Earth's surface. Scientists have estimated that the average global surface temperature of the Earth would be about minus 18 degrees Celsius if the atmosphere didn't exist. The Earth would become a frozen world unsuitable for human habitation. Luckily, we have greenhouse gases to prevent this from happening. Some people say that the atmosphere is like the glass panels of a greenhouse, as it lets solar energy in and prevents some of the heat from escaping, thus making the Earth warmer. This phenomenon is called the greenhouse effect. However, this analogy is not accurate. A greenhouse is able to trap heat because its structure prevents heat from escaping via thermal convection. But since everyone is already used to this term, scientists didn't go out of their way to change it. We can use the sink to elaborate on the concept of energy balance. Let's say the water inlet represents the sun, warm water represents solar radiation, and the bottom outlet represents the infrared radiation emitted by the Earth. If 1 liter of water goes in and 1 liter of water comes out, then nothing will accumulate in the sink. This is what the Earth is like when it doesn't retain any solar radiation. This is a state of energy balance that makes the Earth frozen. However, if we put a basin in the sink, warm water will be stored in the basin. The basin acts just like greenhouse gases do. It will retain some of the solar heat on Earth. This is another state of energy balance, but it makes the Earth warmer. With the presence of greenhouse gases, the average global surface temperature stays at about 15 degrees Celsius. This is a comfortable temperature facilitating the survival of all living beings, so that they can reproduce, giving rise to a biologically diverse and colourful world. However, nothing can be taken for granted because the global energy balance doesn't always stay the same. If the amount of greenhouse gases increases, this is like changing the basin in the sink to a larger one. As more infrared radiation is prevented from returning to space, the global temperature will rise and a new balance will be reached. However, if the temperature continues to rise, will the Earth still be habitable? This concern is based on facts. Look at this star. With the exception of the Sun and the Moon, this is the biggest celestial body that we can see on Earth. This is the planet Venus. The atmosphere of Venus is mainly comprised of one of the greenhouse gases, carbon dioxide. Carbon dioxide is so effective at retaining the heat from the Sun that the surface temperature of Venus can reach 400 degrees Celsius. It is very difficult for organisms to survive in such temperatures. The question is, what would happen if our Earth contained such amounts of greenhouse gases? Since the Industrial Revolution, human activities have been releasing a significant amount of greenhouse gases into the atmosphere. In the late 19th century, the scientist Svante Arrhenius began to suspect that as mankind continued to burn fossil fuels and release large amounts of carbon dioxide, the global temperature would rise. However, he was optimistic at that time.
I estimate that if the atmospheric concentration of carbon dioxide is doubled, the global surface temperature will increase by 5 to 6 degrees. However, please don't worry, because this situation will only happen after 3,000 years, assuming we burn fossil fuels at the current rate.
Was this prediction too optimistic? In 1957, the young scientist Charles David Keeling began to dedicate his whole life to this task. He chose a 4,200-meter high dormant volcano on the Hawaiian Islands, far away from all industrial activities, to conduct his observations. It was here that he drew the famous Keeling curve. In just 46 years, from 1959 to his death in 2005, Keeling's measurements revealed that carbon dioxide concentration had actually increased by 20%. That's right, 20%. People didn't realize that the impact of human activities on nature could be so severe until they saw this figure. The carbon dioxide concentration in the air was approximately 316 ppm in 1959. By 2013, it had increased to approximately 396 ppm. If we look at the statistics starting from 0 AD, we will find that the trend of sharp increases of carbon dioxide began around the year 1900.
In fact, according to estimations by scientists, atmospheric carbon dioxide concentration was about 280 ppm prior to the Industrial Revolution. This meant that in the past 100 years, the concentration of carbon dioxide has increased by more than 40%. Furthermore, in the ice cores drilled in the Greenland and Antarctica, scientists found many small pores created in the ancient past. Scientists analyzed this air from the ancient past and was shocked to find that over the past 800,000 years, carbon dioxide concentration levels had stayed within the range of 180 and 280 ppm. The concentration of 400 ppm that we observe today is unprecedented. From this, we can see that human activities have increased carbon dioxide emissions tremendously.
Although statistics indicate that the amount of greenhouse gases is increasing, do we have any evidence to prove that global warming is happening?
The United Nations Intergovernmental Panel on Climate Change, or IPCC, published the last part of the fifth assessment report in November 2014. The report confirmed that warming of the climate system is certain. Human beings' influence on the climate is very clear. There are many indicators of climate warming. Let me introduce some of them here. The first one is from global surface temperature. The global surface temperature increased by 0.85 degrees from 1880 to 2012. Each decade over the last 30 years has been warmer than the last, with the first decade of the 21st century being the warmest recorded since modern measurement devices were used. Over the past century, a warming trend has been observed in almost every corner of the Earth. Glaciers, ice caps, and ice sheets on the land are also diminishing. Over the past few decades, more than 600 glaciers have disappeared, and the majority of the remaining glaciers are shrinking. More than 200 billion tons of glaciers are being lost per year, and the rate of loss is increasing. And we haven't even taken Antarctica and Greenland, the world's two largest ice sheets, into account yet. Using satellites to observe the Greenland ice sheet, NASA has found that the ice cover has continued to shrink over the last 10 years. From 2003 to 2012, the average annual rate of loss was about 280 billion tons. As a matter of fact, more than 90% of the heat that is trapped on Earth because of greenhouse gases is absorbed by the ocean. The amount of heat absorbed by the ocean has continued to increase over the past few decades. The meltwater from glaciers, ice caps, and the Greenland and Antarctic ice sheets flowing to the sea, together with the expansion of seawater due to heat, is causing sea levels to rise around the world. The rate at which the average global sea level has increased since the mid-19th century is faster than the average rate over the last 2,000 years. In addition, the rate of sea level rise has accelerated over the past 20 years.
Wait a minute. It was said that an increase in solar radiation would also cause global warming. Is it possible that the current warming is caused by stronger solar radiation?
No. According to the data from the past 30 years, the amount of solar radiation that has reached the Earth has followed the changes of the 11-year solar cycle and has not increased significantly. In fact, there was actually a slight downward trend. So, we cannot explain the phenomenon of global warming due to an increase in solar radiation.
I have heard that the inclination of the Earth's rotation axis can change. A change in the inclination of axis will affect temperature. How can we be certain that global warming is due to human activities and not the change in the inclination of the rotation axis?
This student is talking about the Milankovitch cycles. A long time ago, the surface temperature of the Earth fluctuated according to a certain pattern. In the early 20th century, the Serbian scientist Milankovic proposed a theory of using 3 parameters of the Earth's orbit to explain the periodical changes during the Ice Age. The first parameter was related to the Earth's orbit. We know that the Earth revolves around the Sun and that the orbit is slightly elliptical. But the shape of the Earth's orbit, that is, the eccentricity, changes about every 100,000 years. The second parameter is the inclination angle of the Earth's rotation axis. This varies between 22.1 degrees and 24.5 degrees and changes about every 40,000 years. The third parameter is the precession of the Earth's rotation axis, which refers to the movement of the Earth's axis. It changes about every 26,000 years. The precession changes the oblique direction of the Earth's axis at perihelion and aphelion. Milankovic suggested that these 3 parameters affect the amount of sunlight received in high-latitude regions, especially in the northern hemisphere. If there is a decreasing trend in the amount of sunshine received during summer, the temperature rise in summer will be insufficient to melt the ice of the previous winter. Therefore, the amount of ice for the year will increase as a whole. The increase in ice will reflect more sunlight back into space and further reduce the heat absorbed by the Earth. This will further increase the amount of ice and snow, creating a vicious cycle. The increase of ice year after year will eventually drive the Earth into an ice age. This theory proposed by Milankovic was finally confirmed to match the pattern of change of the ice ages. According to the Milankovic cycles, there is currently a downward trend in the amount of sunlight received in the high-latitude regions of the Northern Hemisphere. This matches a research result from January 2013. In the past 5,000 years, the Earth showed a slow cooling trend, but in the recent 100 years, a sharp rise in global temperature has completely reversed the cooling trend of the past 5,000 years. Therefore, the Milankovic cycles cannot explain the global warming phenomenon of the past 100 years either. In fact, scientists are already able to use climate models to simulate global temperature. If we consider only natural factors, the global temperature should be within the blue range. This doesn't match with the real situation shown by the black line. It is impossible to have had the global warming phenomenon since the last mid-century. However, if we consider both natural and human factors, including human greenhouse gas emissions, then the model can simulate the real situation, as depicted by the range in red.
Everything seems clear now. The global temperature rise of the past 100 years was caused by human activities. And 2 of the most significant of these are 1. The burning of fossil fuels, such as petroleum and coal, as power sources by human beings. The combustion process releases large amounts of carbon dioxide. 2. Deforestation. In order to reclaim land, mankind has been cutting down trees. This act of destruction has reduced nature's ability to absorb carbon dioxide. Human activities produce large amounts of greenhouse gases. The trouble is that once they've been released into the air, it takes a long time for them to be reabsorbed by nature. For example, methane needs 12 years, nitrous oxide needs 120 years, and carbon dioxide needs more than 1,000 years. This means that even if we stop all our greenhouse gas emissions today, global warming will still continue for a long time. With global temperature getting higher and higher, do we still have enough time to solve the problem of global warming?